should nowhere close to be empty. Nowhere close. You should have pictures everywhere because you can't write right on top of the computer screen. Please don't. Somebody does it every year, then they get in trouble and it's a big fiasco because your parents get mad that the school wants to charge you for the price of the computer, and legally they're allowed to. So don't do it. Yes. And then your parents are going to refuse, and then you won't be able to graduate because you have dues due. It's not worth it. You have paper. Guess what? Take that paper, put it up to the computer screen and trace it, and then put it back down. Or just sketch the picture. It's really not that bad. Alright, so you have a 20-foot ladder leaning against the wall. What does that look like? Don't draw this stuff where it looks pretty. This isn't art class. That's what it looks like. Everything's straight lines. 20-foot ladder leaning against the wall. The foot of the ladder is 7 feet from the base of the wall. That's telling you right here. This is 7. What is the approximate? Whenever you see that word, you might get a fraction or a decimal. Approximate measure of the angle of the ladder which forms with the ground. So we want this angle here. As soon as you're trying to find the angle, I'm looking for an angle. That means it's trig, but it's not sine, cosine, and tangent. It is going to be the inverse of sine, cosine, and tangent. You notice they don't have any inverses on here. You have to know that if you're looking for an angle, you are going to use the inverse function, but all that means is you're changing this A with everything on the other side. For all of them, they just flip sides. That is the inverse. So first, let's determine if we're using sine, cosine, or tangent. This is my angle. What side of the triangle is that? Adjacent. So I have adjacent. What side of the triangle is the 20? Hypotenuse. What trig function uses adjacent and hypotenuse? Cosine. So it's cosine, but it's not. Why did it freeze? There you go.
I'm looking for the angle, not a side. But my ratio, my fraction, stays the same. Cosine is adjacent, which is 7, over hypotenuse, which is 20. Now plug in the calculator. Go ahead. What do you say? In the calculator, you are going to do exactly how it says, except when you get to the trig function, you have to do the number first. So I'm going to do that fraction first. 7 divided by 20 and hit equals. Then it's inverse cosine. So it's second cosine, hit equals. There's your answer, 69.51, which is B. You're going to do the fraction first. So it's 7 divided by 20. Okay. Then second cosine, because you're doing the inverse cosine. There's your answer.
What happens if you don't press second?
Which was the second?
The green button. The one that says second.
So second and then cosine?
Yes. That gets you the inverse. If you don't hit inverse, then you're going to get the wrong answer. You're going to get an answer. But it's not going to be
Yeah,
that.
because the first time I got 7 point something.
It's 7 divided by 20?
Yes, that's the fraction. Equals
second cosine.
Second cosine, there's your answer. If you get the wrong answer, you don't see your answer choice there, look at your problem. You might have did the wrong trig function. You might have done cosine instead of inverse cosine.
I know when something's inverse, when it's inverse.
When you're looking for the angle.
Not for the side.
If it's a side, it is sine, cosine, tangent.
But inverse is angle.
Angles only.
And for the formula, how does it change? It just goes around?
Yes, your fractions, your ratios go where the angle goes, and your angle goes out here. For inverse, this fraction, like sine, inverse, this is going next to the sine instead of the A. So it's opposite over hypotenuse. And then your A goes out there. Does that make sense? How does that not make sense? Oh, you're taking this, and you're going to put it right there. Then you're going to take this, and you're going to put it right there.
What do you mean put it right there? What?
Who understands what I'm saying? All right, say it another way. I don't know how else to say it. Shh, I said Bryce.
You just move the A and switch it to the end of it, and then take the fraction and move it.
This is when they get equal to A. This is when they don't give you the angle.
Correct.
That's when you use opposite.
Okay.
Do you? Are you sure? Why did you get it when he said it, but not when I said it?
I got it when they both said it.
Okay. A little bit of both. Gigi, what did you say? You about to say something?
So you're just like flipping them around, but how do you know what the angle is the one that they're giving you?
If it's like this, yes, they gave you the angle. If it's
And-
like
and-
this, no, you're looking for the angle.
Yeah, so the other one you're looking for the angle, and the other one you're looking for the side.
Yes, this one, inverse, you're looking for the angle. This, you're looking for the side. We good? All right. Everybody have this that wants it?
Here.
Number 5. What is true? So here's a day one question. What is true of a rhombus that is not true of all other parallelograms? So we got to remember the rhombus. We got to remember our family tree. Maybe draw the family tree. So you had quadrilaterals, that's just 4 sides. Then you had 3. This was the kite. This was the parallelogram. This was the trapezoid. Then from the parallelogram, you had a rhombus, a rectangle, and both of them created the square. So we're talking about the rhombus right here, which is a parallelogram. Remember, if you go up, it's always. So a rhombus is a parallelogram. The definition of a rhombus was just 4 congruent sides. So right here, I have 4 congruent sides where opposite sides are parallel. So what is true of a rhombus that is not true of all other parallelograms? Opposite angles are congruent. Well, that's true in a parallelogram, so it's true in a rhombus. Are opposite angles congruent in a rectangle? Yeah, because all angles are 90. So that's not my answer. Diagonals are congruent. Are diagonals congruent in a parallelogram?
What?
Are diagonals congruent? Actually, it says all other parallelograms, doesn't it? Are diagonals congruent in a square? Are diagonals congruent in a parallelogram? Or a rhombus? In a rhombus?
No.
No. Diagonals bisect each other. Is that true in a rhombus?
No.
Is that true in a rectangle? It is not true in a rectangle. Diagonals do not bisect each other in a rectangle. Diagonals are perpendicular. That is not true in a rectangle. Actually, I take that back. That's true. This is not true. Diagonals bisect each other in parallelograms, so they dissect each other or bisect each other in all of them.
So when you're going up, it's always, and then which one sometimes?
Down.
Going down, and not true.
Not true is if you go left and right. That would be a never. A kite is never a trapezoid because I went from left to right.
So going down is never?
No, going down is sometimes.
Where's the rhombus?
So you have always,
That's what I'm doing, the up and down.
sometimes,
And then side to side, never.
never.
Because a kite will never be a trapezoid, but a kite is sometimes
We
a
always
square.
play that game, I never got it.
A rhombus can never be a rectangle.
Yeah, because it's sides to sides.
Wait,
But
which
if I
one?
say a square is let's say a rectangle, it's always going to be always.
A square is always a rectangle, but a rectangle is sometimes a square.
Which one is the rhombus?
This one.
The other one's the kite.
And the
I
one,
know they kind of look the same.
the one to the right on top is what, parallelogram?
This? Yes. So all of these are parallelograms. Questions?
I thought the top one was the parallelogram.
No, that's just a quadrilateral.
How do you know? Like,
The only thing this one has is 4 sides. How do you know what?
the difference between a kite and rhombus.
The kite, the definition of a kite are consecutive sides are congruent. A rhombus, all 4 sides are congruent. So in a kite, I'll draw a better picture. In a kite, this side is equal to that side, this side is equal to that side.
Mhm.
In a rhombus, all 4 sides are equal.
How do you know if the diagonals bisect each other?
In a parallelogram, that is always true.
And if they are perpendicular?
Perpendicular in a rhombus and a square. Diagonals are also perpendicular in a kite.
And congruent is rectangle.
Congruent would be rectangle and square.
The lines,
And an isosceles trapezoid.
are they congruent?
Huh?
The lines, the 2 lines?
Yes. This is telling you these 2 are congruent, and then these 2 are congruent.
What's the difference between 1 or 2?
It's just to separate the fact that this is not congruent to that. If I put 1 on all of them, that just means all of them are congruent. So to distinguish between the 2 sets, I have 2 different sets. I have this set, so they're congruent. These are different than those, so I just added another line. But these are both congruent. We're good? All right. Another ladder. Here's your ladder, leaning against the building. The ladder's 30 feet long. The angle between the ladder and the building is 15 degrees. Ladder and a building, that is this angle. About how far is the foot of the ladder from the building? So they want to know that side. Here's your angle. This is 90 degrees. Here's your angle. So what side of the triangle is that? Opposite. And the 30 is labeling? So the trig function I'm going to use is? Sine. Sine. Did they give me the angle?
Yeah.
They gave me the angle this time. So I'm using sine of the angle equals opposite x over hypotenuse 30. If the variable is in the numerator, that means you're going to take the number that's in the denominator and you are going to multiply it out front. So this turns into 30 times the sine of 15 degrees, and it's going to give you your x. Again, typing this into the calculator is where we need to really pay attention.
How do you know it's sine?
because it's opposite and hypotenuse. If you look at your trig functions, there's only one that uses both opposite and hypotenuse, and that's sine. Them giving you those two sides tells you exactly which trig function to use.
So from the 90-degree angle, the one going straight across would be the
Hypotenuse.
hypotenuse.
Every single time.
And then the one to the right side is the adjacent.
Yes.
And then to the
Well, the one straight across from the angle they gave you is always going to be opposite. So if you draw a straight line here, you know your hypotenuse. If you draw a straight line here, you know your opposite. There's only one left. That's your adjacent.
Is it A?
It's D.
I don't know. Let's do it. So you're going to do 30 times. Once you get to the trig function, type it in reverse. So it'll be 15, then sine, equals 7.76. So it's A.
Oh, what the?
What'd you do wrong?
I don't know.
30 times.
yeah.
Then you do the angle first. So 15, then sine, not times sine. It's just 15 sine.
Huh?
Then equals.
What?
Precious.
Precious, what's wrong?
Oh, goodness.
Okay, you got your calculator?
Yeah.
This right here is telling you to multiply 30 times the sine of 15. This does not say 30 times the sine times 15.
Oh.
This is the sine of 15.
Uh-huh.
This is your term, that right there. So it's 30 times, and now you're going to do it in reverse. Number first, then sine,
Oh.
then equals.
Oh.
So you
Okay,
multiply,
thanks.
but at first you multiply sine by 15.
No, you don't multiply.
You change 30 to sine.
I multiplied 30 times. This is exactly what I did. Ready? I did 30 times 15 sine, then equals.
Oh, so okay, so it's like this, you move it to here.
Yes.
The angle has to go first.
Yes. You're going to do everything exactly the way it looks until you get to that trig function. Once you get here, this is a term in itself. At that point, you do the angle, then the trig function, then hit equals. Do not put add, subtract, multiply, or divide in between these two pieces. There's nothing in between that. It's this, then equals. Oh, look at that. Two sides of a square represented by that. What is the perimeter of the square? Huh? That looks aggravating. Number 8.
Two sides of a square are
What?
How do you know if they're going to be equal to each other or they're going to equal more than 80?
Well, it's a square.
Oh.
All sides are equal on a square, right? So then they're equal. X squared plus 8x equals 5x plus 28. Here's the problem. That guy. That's a quadratic.
What do you,
We have to take this and set it equal to 0. So you have x squared. You're going to subtract 5x from both sides. So you have plus 3x equal, or nope, not equals, because you're going to subtract 28 to both sides. Minus 28 equals 0. You have to use factoring. Do we remember how to factor?
Nope.
Were we taught factoring? Yeah. You were supposed to be, chances are, I don't know. So we need, when you factor, does this look familiar? Where you had ax, nope, not that. You had ax squared plus or minus bx plus or minus c equals 0. And you might have not had an a, it might have been x squared plus or minus bx plus or minus c. Regardless, what I need to do here, I need to find two numbers that multiply to 28, negative 28, but add to a positive 3. You multiply to the last term, you add to the first term. I'm going to make this easy for you. You see the signs? This is my first sign. My first sign is positive. My second sign is negative. If your second sign is negative, that means your two terms that you're looking for are one of each. One's positive, one's negative. If this sign is negative, you have one of each. If this sign is positive, they're both the same.
You need to find a factor that goes into 28 but adds up to 3.
Yes. And you need to find two. And because this sign is negative, one of them is going to be positive, one of them is going to be negative. Because how do you get a negative number when you multiply? You have to multiply a positive times a negative. This tells you that the larger number is going to be positive. So take 28 and create a factor tree. What are all the numbers that go into 28? Well, 1 and 28. Let's start from the beginning. 2 and 14. 3 doesn't. 4 and 7. 5 doesn't. 6 doesn't. And there's 7. So that's it. Now, what I just said. One's positive, one's negative. The larger one is positive. So I'm going to come over here and make all the smaller ones negative. Now look at all your pairs. When you add these together, what's 28 minus 1? 27. What's 14 minus 2? 12. What's 7 minus 4? 3. So which one added to 3?
Negative.
These two. So there's your answers. Your answer is x minus 4, x plus 7. And now you have to solve each of those for x. So you have x minus 4 equals 0, x plus 7 equals 0. Solve for x. This says x equals 4. This says x equals negative 7. Here's the problem. You have two answers. Only one of them can work. Which means when you plug it in, one of those two answers is going to give you a negative number. Can you have a negative side length? Not a chance. Which one's going to give you the negative number? Well, if you look right here, if I multiply 5 times negative 7, what does that give me? Negative 35 plus 28 is still a negative number. This is not your answer. This is. So plug in 4. 4 times 5 is
20
plus 28 is 48. They want the perimeter of the whole thing. There's 4 sides on a square. So this is 48, this is 48, this is 48, this is 48.
So the x can never,
So it's 48 times 4.
the x can never be negative.
We'll go over it again.
No, like, you chose the other option because it was positive. So it's not supposed to be negative.
It can be negative if, when you plug it in, you get a positive number. But when I plugged this in, I got a negative number. So that's why this one didn't work. Not because the 7 was negative, because when I plugged it in, my answer became negative. You sure it's 192?
Yeah.
All right.
Wait. You plugged in the 4 and the 5x minus 20.
And it doesn't look like
It's a square, right? It's a square?
Yeah.
So all sides are equal, which means this side equals that side. I plugged it into the one that looked more appealing to me. This one just looks easier. If I plugged it in here, I'm going to get the same answer because a square, all sides are equal.
Oh, okay.
But this one, I'm squaring a number, then multiplying it by 8 times that number. That's just too much. So I just plugged it in this one, which is just 5 times plus 28.
Who does the EOC?
What?
Who does the EOC?
What do you mean, who does it? You do it.
No, who makes it?
The state of Florida.
And who's people?
I believe they have people who create test questions. I think most of them are just retired teachers who don't like kids. That's what it seems like anyways.
If you don't
Or they want to
kids,
teach,
don't
but
work.
they just don't want to teach kids.
Simple as that.
No, I'm not saying they don't like kids. The way they word their questions and the type of questions they use, you would think they don't like kids. But it's gotten better. It's definitely gotten better throughout the year.
Would you do that?
Do what?
Do questions instead of teaching?
No. We got this?
Yep.
Do I need to explain it again?
No. It's such a small problem that you wouldn't think it would be hard.
I'm telling you, when you read your EOC, the ones that look the easiest are going to be the hardest. The ones that are really wordy and they're using a whole bunch of words to try to confuse you, those are the easiest questions. Alright, the angles of a quadrilateral are right there. What's the value of x? No. This one's very short, right?
No, it's not.
What does this mean?
No.
What does it mean?
They're not equal to each other. Remember quadrilateral was like that.
Oh yeah.
Quadrilateral only tells you how many sides there are. How many sides are in a quadrilateral?
4.
So, there you
And
go.
it has,
Is that what it looks like? I don't know. But is that a quadrilateral?
yes.
Hell yeah, it is. Can everybody's quadrilateral in this room look different? No. So, these are the angles. They're angles. How many angles are in a quadrilateral?
4.
How many angles did they give me?
4.
Alright, so guess what? This one is 9x minus 1. This one is 5x plus 12. Did they tell me where to put them? That's awesome, because then I get to put them wherever I want. What do you know about all the angles inside of a quadrilateral?
They're equal.
They're not equal. Depends on the quadrilateral. No? All the angles inside of a quadrilateral, when you add them together, should equal
180.
No. 360.
No.
90?
how many? All the angles in a triangle, which is called the Triangle Sum Theorem, add to what? 180 degrees. So if I did this right here, see this? Watch. Ready? Bam! How many triangles do you see? 2. So how many? What is the total number of degrees that should be inside the green shape, since there's 2 triangles in there? 360.
Oh.
Oh, so it's only for the triangle.
A triangle only is 180. Everything else, to figure out how many degrees are inside total, is n minus 2 times 180. The n is the number of sides. Because you can fit n minus 2 triangles inside of any shape. That's why you're multiplying it by 180, because a triangle is 180 degrees. So in a quadrilateral with 4 sides, 4 minus 2 is 2. How many triangles did I have? 2. So 2 times 180, 360. That tells you how many degrees are total inside of any shape. So if this is supposed to equal 360, then I gotta do 9x minus 1 plus 5x plus 12 plus 6x minus 11 plus 4x equals 180. It looks bad, but you're about to condense it.
Because you combine like terms.
Add up all your x's. Here's 9 and 5, which is 14, and 6, which is 20, and 4, so you have 24 x's. So now this, and this, they're all gone.
Wait.
It's 360.
Oh, that was kind
I did that on purpose to see if you could catch my mistake.
That's a lot.
Good job. It's not a lie. How do you know? Prove it. Can't prove it.
Mess up.
I never mess up.
Whoa.
Look, DJ spoke.
You see, as soon as I said that, my computer shut off because they thought it was funny too. All right, now combine your constants. You got minus 1 plus 12, which is 11, minus 11, 0. So 24x equals 360. So 360 divided by 24 is?
15.
That's x. Did they tell you to find x? So you're done. So that problem, very vague. Draw a picture.
What if they ask like for something else?
Then you're going to take x and plug it in. They can ask like, what's the largest angle? You got to plug it in all of them and see which one's bigger. What's the smallest angle?
They won't ever ask you what's the middle angle, right?
I have never seen that. That would be a very stupid question. It's always either the largest or the smallest.
A dead tree was
Keep going, I'm just waiting. You just stopped mid-segment.
So, 360, what about
I didn't say anything. Why'd you just stop like that?
I'm sorry, it was fun.
And that's fine. I was waiting before I moved the paper. I wanted to make sure you still had this to explain it.
So the answer is 15.
Yes. Alright, here you go. A dead tree. That's my kind of tree. Was struck by lightning. Now it's going in my fire pit. Causing it to fall over at a point 10 feet from the base. So this is 10. If the fallen treetop forms a 90-degree angle with the ground, this is 40 degrees. About, so it's a decimal, how tall was the tree originally? So you need to find, actually, how are we going to find this? How are we going to figure out how tall the tree was?
By combining.
Yes, keep going.
Combining the it would be the, what? It would be the opposite.
With?
Oh,
No,
no.
you're
The
opposite.
opposite is the adjacent?
See this?
Yeah.
Hypotenuse. I need to find out the length of the hypotenuse, add it to the piece of the tree that's still standing, and that'll tell me how tall the tree was.
Asking for the whole tree.
So what trig function? So sine, they gave me the angle, so I'm not using inverse. Opposite 10 over hypotenuse. This time, my variable's in the denominator. When your variable's in the denominator, you're going to take your variable and you're going to switch it with everything that's on the other side. They trade places.
So is it inverse?
No, it's not inverse because I'm not finding the angle.
Oh.
This is going to look like x equals 10, the 10 did not move, over sine of 40 degrees. Yes, but how are you going to type in the sine of 40?
What do you do sine 40 first and then?
No, you do the problem in the correct order. So in the calculator, and if you typed in a fraction, it would always be numerator divided by denominator. So it's 10 divided by.
You have to round it?
Then it's going to be, once you get to the trig, it is 40 sine, then equal, and yes, it said about, so it is 16 feet. Well, no, that almost got you. That's the hypotenuse. That is the hypotenuse. See that? We did all that work. We got an answer. The answer was there, so I jumped all over it. Hell no. I just got that question wrong because I was too cocky. Because that's the hypotenuse. That is this. What is the question? How tall was the whole tree? So it's your hypotenuse, which is 16, plus the piece that's still standing.
So it'll be 26.
Always, when you are done, always go back to the question. Does your answer their question?
So after you round it, you add.
What's up?
No, he was asking a question.
After what?
You round it, you add the 10 to it.
Yes,
So that's how you find the whole thing.
the whole thing.
How'd you get 26?
16 plus 10
You mean plus?
plus. I said plus. Did I not say plus? I said plus. Questions?
No.
Anybody still writing it?
What are you writing 16 plus 10?
Because they asked for the how tall was the whole tree. So this is part of the tree. The 16 was just this part. So I have to add them together. Thank you.
What is that?
Your work?
EOC?
No, after the EOC.
Nice that's geometry neat.
So we're doing all of that after we take a
Yeah,
What is it, a test or just work?
work. And then you'll have the test.
Do we have any more unit assessments?
for 2 days.
Is school over? Are you going to stop coming to school after Tuesday?
No.
Then we are not going to stop learning. It's called you go to school to learn.
The test.
Yeah,
You have to be tested on what you did or did not learn. So you're used to it.
No, I'm not. It's bullcrap.
Write your senator.
I mean,
My uncle just became a math teacher since high school.
Alright, next page. If you have the packet.
Who has the packet?
Yeah.
See? You see? Melanie, you got a packet? No.
It was fighting in your room.
What is it like this? Wouldn't this be, that's good.
Alright. This is a trapezoid.
you have to find a median.
They gave you the median, which is this. The median means it's in the middle.
Isn't it where you add it and then?
What is the length of AB? To find this purple line, you are going to add, that equals base 1 plus base 2 divided by 2. The median is base 1 plus base 2 divided by 2. See how they gave you something in all three places? So, what is this? 12 equals base 1, x minus 5, plus base 2, 2x minus 1, divided by 2.
Oh, wait, I'm confused.
The median, the line in the middle of a trapezoid, is equal to you adding your two bases and then dividing it by 2. So this equals this plus this divided by 2. So this equals this plus this divided by 2. The very first step is to get rid of that 2. Multiply it to both sides. When you multiply it to both sides, you get 24 equals. I'm going to combine these terms. So you'll have x and 2x, which gives you 3x, negative 5, and a negative 1, which give you a negative 6. Multiplied it by 2.
Why?
To 12. I took this. I don't like fractions. Do you like fractions?
I mean, that was kind of easy.
So you take it and you multiply it to that side. Add 6 to both sides. 30 equals 3x. Divide by 3. x equals 10. Does it say find x?
AB.
No, it says find AB. Where's AB? AB's up here, so it's going to be 10 minus 5, which is?
But I'll do what you put 12 equals. What the?
I didn't see that part.
Is that 5 or?
You don't get what?
Well, you put 12 equals.
Because 12's the median. Remember, the median, the line in the middle, equals this plus this divided by 2?
Oh, that's a 12.
That's a 12.
I'm sorry, I can't see.
That's fine, it's really small.
What are the bottoms is 2x minus 1?
Huh?
The bottom, this is 2x minus 1.
Can you see
That's
that?
better.
That better? That's still not better. Is that better? That's x minus 5 on top, 12 in the middle, 2x minus 1 on the bottom.
It looks like r minus 5, but it's x.
What happens if, let's say like in that trapezoid, there's two different variables?
Good.
Like there's r minus 5 and there's x, whatever. That's not gonna happen.
Oh,
That can happen, not in the trapezoid. If that happens, you set up a system of
okay.
equations.
I got a question. Why you put 5 is if the x was 10?
Because it says to find the length of AB.
After I found x,
Oh,
the
I
question,
divide by 2.
your question is you find
No,
AB?
you don't divide by 2.
The 10 you divide by 2?
No.
No.
It says find the length of AB. What's AB? AB's up here, which is x minus 5. So 10 minus 5 gave me my answer.
Nice.
Can we go on?
Yeah. Do you have paper, Mr. Coco, please? Thank you.
All right. If KLMN is a rhombus, this is big. This tells me that all of these sides are equal because all of those sides are equal in a rhombus. It also tells me that your diagonals are bisected, so these are equal, and it tells me they're perpendicular. That's just knowing the properties. One of the things that I just said is going to help me answer this question. KLM is 80. The whole thing is 80 degrees. What is the measure of angle 1? Alright, here goes. In a rhombus, there was one thing that I left out. Your diagonals bisect the angles. So this angle has been bisected. So if the whole thing is 80, what's this piece? 40. This is 90 degrees, so I'm only focused on this triangle because that's where my angle 1 is. If this is 40 and this is 90, what is that one?
50.
Wait. Reggie, you can't wait.
Oh, Mr. Coco, this is the most confusing one.
Wait until I finish, please.
I'll do it again. Let's wait for
Precious.
to draw her picture.
It looks like a kite.
It's not a kite, it's a rhombus. How do you know? Because it says it right there.
No, I'm saying it looks like.
Nothing in this class looks like anything.
Mr. Smarty Pants thinks
So
he
you don't
knows
like the
everything.
Everything is exactly what they say it is.
Okay, I'm good.
So I can go over it now? Alright, should I erase it?
That's so cool.
Alright, so let's go back. The fact that they said it's a rhombus, I'm not going to mark it all up. I just know all that stuff is true. Let's see what they give you. They gave you that this angle is 80 degrees. Well, in a rhombus, your diagonals bisect the angles, and your opposite angles are congruent. Let's see which one you need. They're asking you to find the measurement of angle 1, which is in this triangle.
So if I remember that the diagonals in a rhombus bisect the angles, that means this angle in here is 40 degrees. It's half of 80. Your diagonals are also perpendicular, so that's 90. You have 90 plus 40, which is 130. What are we whoaing? Then to find angle 1, it's 180 minus 130, which is 50
Why
degrees.
do you do 90 minus 40 equals something?
You can do 90 minus 40 equals 50.
But the other way is 160.
Either way. If it's a right triangle, then 180 minus 90 is 90. So then yes, these two angles have to equal 90 degrees. 90 minus 40. Just do it this way. Just do it this way. Don't listen to anything I just said. Just do it this way. Do it this way.
Which way?
This way.
The 90 minus 40.
90 minus 40.
Instead of doing 90 plus 40 and 80.
Wait,
Oh,
but
Precious.
why you
did it, Gigi.
put 90? But
What, Precious?
She's talking to you.
You said wait first. Go
Oh,
ahead.
never mind. Now it's just cutting
Okay,
in half.
so
Perfect.
how'd you get 40?
Because the diagonal in a rhombus bisects the angles, which means it splits the angles in half. So if they told me angle L was 80 degrees, that means angle KLN is half of that, which is 40.
Okay. Okay.
Good?
Got it, yeah. Wait, why KLN?
Because they want angle 1. Do you see where angle 1
Yeah.
is? So I need everything inside that red triangle. So that's why I chose that angle.
But if it was KLN, then N would have been colored too. So it's just KL.
Well, I said KLN because this wasn't labeled. So KLO. That angle. KLO. KLO. I'm talking about this angle right here. Does that make sense?
I guess.
To name an angle, you have to have 3 letters. The letter you say in the middle is where your angle is. So if I said KLO, my angle is the second letter I said.
Okay, let's just move on. I got it.
I feel like you're lying,
I'll
but
study at home.
uh-huh.
Okay, what that means.
The measure of each exterior angle of a regular polygon is 45 degrees. How many sides does a polygon have? Well, here goes. See what this says? When you add all of the angle measures outside of a polygon, they will always have to add to 360 degrees. Outside, the angles outside the polygon, when you add them together, 360 degrees. They will always, that's because every single polygon is inside of a circle. So the outside angles are what creates the circle. So I'm going to take 360, since the exterior angle is 45, I'm going to divide it by 45 to see how many sides this shape has. How many 45 degree angles are there?
Why don't you subtract it?
Because you have to divide it.
How do you have to divide it?
Because you have a shape. How do you draw an octagon?
First of all, when you put 360 because it's supposed to equal 360,
Yes. The exterior angles.
if it's an interior, it would be different.
The interior at n minus 2 times 180. So there's your octagon. You ready? If I did this all the way around,
See how I'm creating angles with the sides? All of these angles, if I added all of them up, would have to equal 360 degrees. So if I told you that one of these is 45, and I asked you how many sides there were, you would just take that 45, divide it by 360, and that tells you how many of these are 45 degrees.
That makes sense, but how do you know the polygonic 360?
Because of this. The exterior angles of any polygon will always...
That's just for polygons.
It's a polygon, which is any shape that is formed by straight sides.
It's always 360.
360. You can try it because a square, right? If I did the same thing, a square, all the interior angles are 90. So that means all of these are also 90. What's 90 plus 90 plus 90 plus 90? 360. I can do that for any shape. We good?
Yeah. What the answer is? 8.
What is it?
Get all lost.
Where you lost?
You go to this chart?
So any quadrilateral.
Any polygon. Polygon is just any shape formed by straight lines.
So circle one equal to 360.
Well, I mean, a circle is 360.
So what's a regular polygon?
A regular means all sides and angles are equal.
Oh.
So, triangle, all the quadrilaterals, pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, dodecagon, 13-agon, 14-agon, any of them. Anything after 12 is just that number agon. Come on, DJ, we went over this. Yes.
Wait. Did you just write that square in there? That square with the 90s?
Yes.
What does that mean?
I was showing you that this one also is 360.
Oh, because it's a stereo angle.
Alright, number 4. In a hexagon, how many sides is that? 6. Notice there's no picture. You have to know this. 3 angles have the same measure. So out of 6 angles, I have 6 of them. 3 are the same. The measure of each of the congruent angles is twice the measure of the 4th angle.
Come on, stop erasing stuff.
So 3 of them. How do I want to write this? So here's 1, 2, 3, 4, 5, and 6. So 3 of them are the same. We'll just call that X. Each of the congruent angles is twice the measure of the 4th angle. So here's the 4th angle. Then I'm going to come up here and multiply all of these by 2 because they're 2 times bigger than the 4th angle. I'll do it again.
Yeah.
Huh? The lines are for each angle. I have a total of 6 angles in a hexagon. So here's angle 1, 2, 3, 4, 5, and 6. Right? Why are you still looking like that?
So instead of doing the shape, you can just do the lines?
Yeah, because I'm not real awesome at drawing a hexagon. So instead I'm just using what's called my brain. My brain. The thing that's between here and here, my brain. It's actually like between here and here. Sorry, I got too excited. I went all the way across. So it says 3 angles are the same. So these up here are the angles that are the same. But then it says those angles that are the same are twice as big as my 4th angle. So here's my 4th angle. So that means all 3 of these are twice as big as that. Which is why I multiply it by 2.
Yeah.
Why are you still looking like that?
So it'll be 2 times 2 times 2 equals a fourth angle?
No, this is 2 times bigger than my fourth angle. What's my fourth angle? X. How do you know if it's 2 times bigger? Because I multiplied it by 2. This is 2 times bigger than my fourth. This is 2 times bigger than my fourth. This is 2 times bigger than my fourth. But all 3 of these have to be equal to each other. We're good so far? This is one of those questions where they're just trying to 100% mess you up. Don't let them. This is one of those questions where we're fighting. It's me or you. You gonna let them win, or are you gonna win? Most of you are just gonna let them win, and you're gonna skip this question. Don't let them win. Give them a throat punch by doing this question. You can't do that unless you do the question.
Do they have EOC practice on the internet with the answer key?
Huh?
Do they have EOC practice in the internet with the answer?
Go to Escambia County. Escambia County Geometry EOC, and it'll come up. Uh-huh. Escambia, E-S-C-A-M-B-I-A. County Geometry EOC Review, and it'll come up. They have questions, and then they have a little link at the bottom. You click the link, it'll explain the answer to you. All right, the fourth angle, twice the measure of the fourth angle, and half the measure of the fifth angle. Let's read that again. The measure of each congruent angle is twice the measure of the fourth and half the measure of the fifth. So how am I going to label the fifth angle? These are twice as big as that, but half of this.
Whoa.
So then what does that mean? How much bigger is the fifth angle than the fourth angle? What's half of 4? Now let's find out what the sixth. The sixth angle measure, oh look, they actually gave me a freaking number. 115 degrees.
There's someone at the door.
Wait. I think she's just giving pencils back.
It's asking you what is the measure of the smallest angle. You have to figure out what's x to plug it back in.
What's? Thank you. Look at those. Look at these. Look at these. What's going to be your smallest angle? Your fourth angle. X.
How?
X. Because it's just x. When you find x and you multiply it by 2, it's automatic.
Angle, and I'm like, how? Thinking for it.
All right. So how are we going to find what this angle is? Well, you have to know what the degree measures of a hexagon should equal. How are you going to do that? N minus 2 times 180. 6 minus 2 is?
4.
4 times 180? Was it 720?
720.
This is the equation for any polygon to figure out how many degrees are inside. Inside. Outside, always 360. Inside, there's your formula. Any polygon, because you're just going to take the number of sides, subtract it by 2, multiply it by 180. There's your answer.
Wait, what?
Take the number of sides,
Whoa. Question.
subtract.
How
Yes.
is this 720? Because 720 divided by 2 is 360.
Wait, so
The angle measures inside of an object can be larger than 360 degrees. The outside is only 360.
I feel this. Wait, so the end is 6, right?
Yes.
You 6 raised to
Times 180.
So inside could be greater than 360, but not outside.
Look,
Is it the same thing for triangle?
same thing for every shape. Watch. No, a triangle can't be more than 180 degrees. Watch. Everything is inside of this. Everything. If I did this, my outside angles would all add up to the circle. My inside angles, right now I can say they're all 90, so they're all 360 degrees. But if I did another shape in here, actually it should be like this.
Can I use
You see how the inside angles are becoming obtuse? So if I have all obtuse angles, all 100-degree angles, but I have 7 sides, then that's 700 degrees. That's bigger than 360. Your inside angles, as you get closer to the circle, your inside angles of any polygon, if this is the circle, your inside angles are just getting more and more obtuse with the more sides you put in them. So the inside of the shape, yes, it can have an infinite amount of degree angles. The outside, however, eventually your angles are going to, or your sides are going to be so many that you create the circle. So your shape cannot be bigger than a circle, which is 360 degrees on the outside. I just confused you even more, didn't I?
Let's just skip this question. It's fine.
DJ?
I think the n minus 2.
That's the formula
To find the degree.
to find the total number of degrees inside of any shape.
And you got 720 from...
Because it's a hexagon, the n stands for the number of sides. So in a hexagon, there's 6 sides. So 6 minus 2 is 4. 4 times 180 is 720. Yes. Now that we know how much these should equal, just add them up and set it equal to each other. So you have, and this is going to be long, 2x plus 2x plus 2x plus x plus 4x plus 115 equals 720.
Just do
Combine them. 2, 4, 6, 7, 11.
But what'd you do with the x?
What do you mean what I do with the x? I added them all. You have 2 x's here. The x alone is right there.
No, but what do you do with the x?
What do you mean what do I do with it?
Because you only put 720 and you forgot about the x.
Look at all these x's. I didn't forget about them. All of this equals 720.
so. Alright, keep on.
Plus 115 equals 720.
Minus 15.
Minus 115, and you
equals
get?
605.
So divide by 11.
Divided by 11 equals 55. You're doing that wrong. How do you know that would be the smallest angle?
Because that's x. X equals 55. Look over here. This angle is 55. This angle is 2 times 55, which is 110. 110. 110. 4 times 55 is definitely bigger than 55. And 55 is bigger than that, so that's the smallest angle.
You just did 11 plus 115.
11x
So you
plus 115 equals 720. To do what?
to get 720.
To get 720, I did this. We're good? Cassandra, do you want all that too? All right. All right, this next one. Good Lord. The next one says it wants to know how big x is in degrees. Do you see where x is? Okay. You ready for this?
No.
All right. Watch when I do this. Let's only worry about that shape. That shape is a what? Pentagon. Is there a way, they said it's regular, so all sides and angles are equal. Is there a way that I can find this angle measure right there? Yeah, it's regular. Is there a way for me to find out what the total number of angles in this whole thing is? Yeah. But it's a pentagon, so it's 5 minus 2 times 180. 5 minus 2 is? 3 times 180 is?
180 times 3 was that like 6? So there's 540 degrees total in this shape. But I have 5 angles that are all the same exact measure. How am I going to figure out what that is? And you get?
108.
So this is 108. Now, if the inside is 108, how big is just this piece on the outside? You see what kind of line that is? It's a straight line. So this is 72 degrees.
How do you get 72?
Because it's a straight line, so this is 180 degrees. If that's 108, 180 minus 108 is 72. We're good?
Wait, where'd you get 108?
540 divided by 5 because there's 5 angles. All 5 angles in here are exactly the same. If all of them add to equal 540, when you divide by 5, it tells you what each one is. So all of these angles are 108 degrees. We're good? All right. Now we're going to do the exact same thing to this question. That's a different shape. You can't see it. That was a blank sheet of paper. That's a different shape. What kind of shape is that? Hexagon. Hexagon has 6 sides. We just figured out that each angle, or all the angles in a hexagon, equals 720. If I have 6 of them that are the exact same number, how am I going to figure out which each one is? Divide by 6. So 720 divided by 6 is? What is it? 120? Okay. So if the inside angle is 120, how big is the outside angle? 60. Now look. How big is angle X? 72 plus 60, which is?
We're going to get something like that?
It's not hard though.
It's not, but looking at it gives you a headache.
And then when you saw this, you like the whole thing.
Because I knew your reaction. I knew what your reaction would be before I even did it. And was I wrong? No. Because I'm going to get the same reaction next year when I do the same exact problem with the same exact group of kids that just have different faces. Guys, you guys don't change. I have a Derek every year.
Bro?
Uh-huh.
Hey, man. It's a common black name.
I'm not saying the name's the same. I have your personality. I have a Christian every year. You would.
Every year?
Uh-huh.
Yeah, which one every year?
You got Kendra.
Not you guys are not unique. I hate to break that to you. Every year I have the same exact personalities.
And just different.
Every single year. The only thing that changes is the shape of your face and your name.
That's a lie. And then Frank walking towards me, not me.
Bro,
I have a Josh every year.
Hi.
Somebody who just loves to wear hats.
Where you
Do you have a Jafari?
so what is me?
Yeah, I have a Kendra every year.
What does it do?
She's my favorite student. All right. We'll probably end with this question. JK and LM are perpendicular. What does perpendicular mean?
They equal to.
No, they don't equal anything. Perpendicular lines create a 90-degree angle. It even goes further. They are perpendicular diameters of a circle. They are each 12 inches long. So what's the radius?
6.
What is the approximate length of chord? Okay, so this is 6. This is 6. They're all 6. So J, K, L, M. It says, what is the approximate length of the chord LK? Here is LK. How am I going to find a green line? Very easy question. This is 90 degrees. This is 6. That's 6. I have a right triangle.
I know 2 out of the 3 sides. What am I going to use to find the third side? The 2 sides, the 2 legs of your right triangle are both 6, so 6 squared plus 6 squared equals c squared, which is 36 plus 36 equals c squared. 72 equals c squared, so c equals the square root of 72, which is definitely a decimal, so it's not that, it's not that.
No. What?
What? That was great.